Hello everyone, I am absent today as you well know, and the reason why is because my wife is having a baby, so I'm very excited. So let's learn our today's material on the video lesson, and then I will touch back with you when I get back. So we're on the substitution method again. What we're going to be doing this time is kind of following the same rules. We're going to get x or y all by itself. Second step, substitute it into the equation. Third step is we're going to solve for x or for y. So on this one here, on yesterday's lesson, we always had y or x all by itself. Now today, y isn't all by itself. It has this negative 2x with it. And in the same way, in the next equation, x is not all by itself. It has the positive 3y with it. So I got to solve for a variable. I got to get x or y all by itself. And it really doesn't matter what equation you get all by itself as long as you get one of them. So we could just pick and choose. It doesn't matter. Let's get this one all by itself. So the way we get y all by itself is we add 2x to both sides of the equation. So now, in this equation, once again, we're going to get y equals, we add the 2x over, so it's a positive 2x, and then I still have this minus 3 over here. So y equals 2x minus 3. Let's circle this, everybody. Please do that with me. And we're going to put that into y. Y equals 2x minus 3. So this y equals 2x minus 3. We're going to substitute it in there. So here's what we got then. We got x plus 3 times y equals 5. X plus 3 times y equals 5. And y is now 2x minus 3. We're going to put that in there. 2x minus 3. And now, class, we're just going to solve for x just like we did yesterday. So x plus, distribute, 6x minus 9. That equals 5. Now that we've done that, we're going to combine like terms. Right here we get 7x's, and add 9, we get 7x equals 14. So then we simply divide both sides by 7, and x equals a positive 2. As you well know on all of these, don't just stop when you get x equals, you got to get x and y. So here's our circled part that we got. Y equals 2x minus 3, so y equals 2 times x, and x we found to be 2, so it's 2 times 2 minus 3. So y equals 4 minus 3, because 2 times 2 is 4, y equals 1. So our answer is the ordered pair 2, 1. And we write that down. The x-coordinate is 2, the y-coordinate is 1. There's my answer. So these are both lines. These lines intersect at the point 2, 1. Here's how you can see it right here. These are both of the equations. When you graph both of them, they intersect at the point right 2, up 1. Okay? Let's try another one. Practice makes perfect. So right now, neither x nor y are all by itself. So I have to solve for x, or I have to solve for y. It doesn't matter which one you solve for. Actually, this x is all by itself. But just for the sake of practicing, let's solve this equation for x, everybody, okay? We're going to get this x all by itself. So a positive 5y, I'm going to subtract you over to the other side so that x can be all by itself. So then we have x equals a negative 5y and a positive 2. When you subtract 5y over, and then you still have this plus 2 right here. So this part right here, we're going to substitute in for this x. So I have a negative 3y equals x. And what is x? X is a negative 5y plus 2. Okay, we've substituted this x, because it's 5y plus 2, into this x. So now we're going to solve for y. Add 5y, and we get 2y equals 2. This is gone, so all we have left is the 2. And then we divide both sides by 2, because we've got to get y all by itself, so y equals 1. There's the y-coordinate. The x-coordinate is found right here now. What does x equal? It equals a negative 5 times the y, and we found y to be 1, plus 2. So x equals a negative 5 plus 2. So x equals a negative 3. So my ordered pair is the point x-coordinate y coordinate, -3, comma, +1. This is my solution. This is where the two lines intersect if we were to graph both of these lines. So notice how on the next page, if we graph both of the lines, it crosses at a -3, +1. All right, why don't you guys try number 3 all on your own, please, okay? Let's see what you get for problem number 3. After you've tried it, it doesn't matter which variable you got all by itself. It would be very easy to get this x all by itself by subtracting 2y. It would be very easy to get this y all by itself by subtracting 4x. So you can do either method and you'd get the right answer either way. I'm going to do the first one. So I'm going to subtract 2y. So that would give me x equals a -2y plus 13. When you subtract 2y from both sides, you get a -2y and a +13. This you're going to put in for this x. That's what x equals. So it's 4 times x plus y equals 38 into this equation. 4 times x plus a y equals 38. And now we're not going to say 4x anymore. We're going to say 4 times what x equals. X equals a -2y adding 13. Okay? Hopefully all of you got that when you did this on your own. Here we have a -8y when we distribute. And here we get a +52. Plus this y, that equals 38. All right, let's clean things up a little bit. So we have a -8y and a +1y make a -7y. And subtract 52, that equals a -14. So now if we divide both sides by a -7, y equals a +2. A -14 divided by a -7 is a +2. That gives us the y coordinate. Now everybody, let's find the x coordinate, shall we? The x coordinate is found right here. So x equals a -2 times the y coordinate. The y is a +2 plus 13. So -4 plus 13 is what x equals. X equals a +9. So my solution, these two lines, they intersect at right 9 up 2. There's my answer for problem number 3. Right 9 up 2. And as you can see, there it is right here. These two lines, you'd graph them. It looks like this, and it crosses at 9, 2. Last problem is a little bit fishy. We have to get x or y all by itself. That's the very first step. So how do we get x or y? Well, in this equation, it's kind of messy. And this equation is a little bit messy too, but I think it's less messy. When you have a coefficient in front of your variable, meaning a 6 or a 2 or a 3, it's harder to get that one all by itself. This one, this y, just has a -1 in front of it, so it'd probably be easiest to get this y right here all by itself. So let's solve for that y. 3x's, I don't want you over there, I want you over to the right side instead. So now these are gone from the left side, and we have a -y. That equals a -3x and a -2. So I got to get y all by itself, not a -y. So if I got to get y all by itself, I got to get rid of this negative sign right here. So that means I got to divide both sides by a -1, and that's gone. Divide this by a -1, so it just changes the sign on everything. So now I have a +y equals a negative divided by negative is a +3x, and a negative divided by negative is a +2. That's what y equals in this case. Y equals 3x plus 2. I'm going to substitute this into my other equation, which is right there. Okay? So it's 6x minus 2y equals a -4. 6x minus 2y equals a -4. 6x minus 2y equals a -4. However, what does y equal? Y equals 3x plus 2. So 3x plus 2 goes right there, because that's what y equals. And now the rest, I hope you feel comfortable with by now. We're going to distribute, and we get 6x minus 6x minus 4, because -2 times 3 is -6x. -2 times a +2 is a -4. That equals a -4. All right, let's clean things up by combining like terms. A positive 6x and a minus 6x make 0 x's, or just 0. And then if we add 4 to both sides, we get 0 equals 0. So what happened over here? Our variables all canceled out, and we actually ended up with a true statement. 0 equals 0. That's a true statement. If that ever happens, class, what that means is that the lines are the same line, meaning that the lines line up right on top of each other. What happens when the lines are the exact same? It's all real numbers, or infinitely many solutions. So if you ever get when you're solving by substitution, if you ever get a true statement like this, like 0 equals 0, or if you end up with 4 equals 4, or 12 equals 12, whatever, if it's one number equals that same number, it's always going to be the same line, which means your solution is infinitely many solutions. Okay? In the same way, if you get a false statement, let's say you end up with your variables canceling out, and then you get 7 equals 3. That's a false statement. So if this ever happens, then the lines are parallel. And what happens with parallel lines? There is no solution. They do not intersect at all. So if you get a true statement, it's infinitely many solutions. If you end up with a false statement, something like this, then the answer is no solution. I hope you guys do okay with this, and then with the quiz on Friday, I will be back with you later next week, and we could touch base at that time. Good luck on today's assignment.